In this video, I will be covering the week 4 lab. And the week 4 lab focuses on the normal distribution, the empirical rule, and the central limit theorem. And those topics are really covered in module 3, so I'll be referencing that. And here at the top of the lab, you can see how you'll be graded on this lab and the breakdown of the score. Part 1 of the lab is to consider iron levels in a population, and it gives you the mean of it, it gives you the standard deviation, and it says you're measuring iron for one specific patient. And then for that one patient, what would be an example of an unusual level of iron for that patient? And describe how you determined it's unusual based on the empirical rule. So the empirical rule only works with normal distributions. And what it tells us is the percentage of data that falls within a certain number of standard deviations. So 68% of data falls within one standard deviation, 95% in 2, and 99.7 within 3. Let me go through an example with some numbers here to make that a little clearer. Another variable that follows a normal distribution is the internal temperature of people. The mean, the average, is 98.6 degrees Fahrenheit. And that is right in the middle of the distribution. The mean is always in the middle of a normal distribution. And that's where the distribution is highest. The height of the curve here is, it's higher means it's more likely that people have that value. So you can see the further we get away from 98.6, the higher data values, the curve is going down because there's less and less people that have a temperature that's hotter and hotter. And it's symmetric, the same as we get less and less than 98.6, there's less and less people that have a temperature, an internal temperature that's less than 98.6. So it's unlikely to be far away below or far away above, but it's very likely to be close to 98.6. In the empirical rule, I'm saying the standard deviation is 0.3 for internal temperature, and I kind of just made that up. To get the exact standard deviation, we would need to do some research. But we're going with 0.3 for this example. So the empirical rule then tells us that if we add 0.3 to the mean, that's one standard deviation above, or subtract 0.3 from the mean, that's one standard deviation below, 68% of the data, 68% of people have an internal body temperature between those two values. So between 98.3 and 98.9. Continuing that process, 95% of people have internal body temperatures between these values, and 99.7% of people, if we add the 0.3, the standard deviation 3 times, we get 99.5. If we subtract it 3 times, we get 97.7. 99.7% of people fall within that range. So when we talk about a typical, a usual value, we usually say anything outside of the 2 standard deviations is unusual. Since 95% of people fall within 2 standard deviations, it's unusual to be further away, either above or further away below 2 standard deviations. It's very unusual to be more than 3 standard deviations away, because only 0.3% of people are more than 3 standard deviations away. So use these values for the mean and the standard deviation. With the empirical rule, find the values that would be 1 standard deviation, 2 standard deviations, 3 standard deviations away from the mean, and come up with a value that would be unusual and explain why that's unusual. And number 2, we're not just looking at one patient's measurement. We're measuring iron levels for an entire group of individuals and looking at the mean or the average of that group. And so again, we want to use the empirical rule. So again, we're going to want to know what the mean is of the distribution and what the standard deviation is of the distribution. And then we can find the values that are unusual or usual based on, how many standard deviations away they are from the mean. Now, when we're looking at a group of individuals and the mean for groups of a certain size, the central limit theorem is what tells us that the samples of the same size, the means of those samples will follow a normal distribution. And so jumping back to the week 3 lesson, we know that if we look at groups of the same size, the mean of those groups will follow a normal distribution. And so our question then is, well, what's the mean of that distribution? What's the standard deviation? The mean stays exactly the same as the population mean. The standard deviation is the population standard deviation divided by the square root of the group size. So whatever size you pick for number 2, you get to pick the group size. The mean of the distribution of your samples stays exactly the same as the population mean. Your standard deviation is going to be this population standard deviation divided by the square root of your sample size. And then once you have the mean and the standard deviation, you can use the empirical rule to find a usual or an unusual value. Unusual values are more than 2 standard deviations away from the mean. Very unusual if more than 3 standard deviations away. Pay close attention to number 2. Here it's asking for a group's mean that would be usual. So number 1 asked for something that would be unusual. Here we're asking for a value that would be considered usual. And then for number 3, pick an area of interest for you in the health sciences and talk about 3 variables in that area that will probably follow a normal distribution or at least be pretty close to one, and talk about why it would follow a normal distribution or be close to one. So for example, I'm going to talk about in this video here life expectancy. So if we had collected data on people's life expectancy, on how long they actually lived, I would expect the mean, the average life expectancy to be right in the middle of our data. And then as we get older and older than that average age, there's less and less people that live to that older and older age. And it would be pretty symmetric. As we get younger and younger than that average life expectancy, there's less and less people that die at that younger age. So I would assume that life expectancy for humans is normally distributed. Now, I would mention also that it's probably not perfectly normally distributed if we considered all people. It probably has a little skew to the left because we do have people who die unexpectedly at younger ages, people who die in wars and natural disasters and accidents and diseases and stuff like that, that could cause a skew where there's more people showing up down here at the lower end than at extremely older age. So it's probably not perfectly normally distributed if we include everybody, but if we changed it to people's potential life expectancy, where we rule out people dying earlier than they should have if they were able to live out their full term of their life, then I think we would see something very, very close to a normal distribution where the average is right in the middle, and we got most people clustered around that, and then less and less people as you go to younger ages, and the same thing with older ages. The further away you get from the mean, there's less and less people, and we have that nice bell-shaped normal distribution. So after you answer all 3 of those questions, make sure your name is on your document and then turn it in. Let me know if you have any questions about any parts of this. I'll be happy to provide more assistance.